Hi friends, now I am going to discuss about basic electricity part 2. In this part, first of all, circuit elements. The circuit elements are nothing but resistor, inductor, capacitor, voltage source and current sources. These are mainly classified into two types. First one, active elements and passive elements. Okay, coming to the active elements, the elements which are capable of delivering the power, like parents in family, they are delivering some money to the children's welfare. Okay, so likewise active elements have capable of delivering power. Active elements. So first one is voltage source. Okay, voltage source, the source in which voltage is independent of current, in the source in which voltage is independent of current. Okay, these voltage sources are mainly two types. The first one is ideal voltage source, second one is practical voltage source. Coming to the ideal voltage source, it is very important for bits. Ideal voltage source, the voltage source in which internal resistance is zero, is called as ideal voltage source. For ideal voltage source, internal resistance is zero. For practical voltage source, the internal resistance is not equal to zero. It may be some value. Okay, at least 10% voltage drop. Okay, all the voltage sources are practical only. Next, coming to the current source, the source in which current is independent of voltage. These are also two types: ideal current source and practical current source. In case of ideal current source, the internal resistance is infinity, but in case of ideal voltage source, internal resistance is zero. It is very important. Okay, in case of ideal voltage source, internal resistance equal to zero. In case of ideal current source, internal resistance is infinity. Coming to the practical current source, the internal resistance is not infinity. Okay, it may be very high value. Okay, next, after active elements, second one is passive elements, the elements which does not capable of delivering power, that means it are capable of receiving the power. Okay, capable of receiving the power. Nothing but children's in a family. Fathers, that means fathers, mothers, or parents are active elements, and children are like passive elements. The passive elements are resistor, inductor and capacitor. Next, I will explain each and every passive elements. First of all, what is first passive element? Resistor. We all know about resistor. About resistor. What is a resistor? Which opposes the flow of current. Okay, which opposes the flow of current is called as resistance, or the element is called resistor. This is the symbol of resistor. Okay, this is the symbol of resistors. The units of resistance we know, ohms. Units of resistance is ohms. The power loss in this resistor P equal to nothing but I square R. The units of power is watts. The power dissipates in the in resistor is in the form of heat. The power dissipates in resistor in the form of heat. Next, coming to the next topic in resistor, that is short circuit. It is very important. Short circuit. Here it is called as short circuit. The two terminals connected by a wire is called short circuit. The wire resistance is 0. If the resistance is 0, here the voltage drop is also 0, because V equal to I into R. If R is 0, V equal to 0. V equal to 0. So for short circuit, voltage equal to 0. That means voltage equal to 0 means it is a short circuit. What is a short circuit? If the voltage equal to 0, then it is called as short circuit. Next, coming to the open circuit, it is also important. Coming to the open circuit, it is the open circuit. For open circuit, the resistance is very high, that is maybe infinity. For if resistance is infinity, the current through this is 0. Current equal to 0, because the resistance which opposes the flow of current. So if resistance is high, the current is small. If resistance is infinity, current is 0 for open circuit. So that means current equal to 0 for open circuit. That means current equal to 0 for open circuit, or I equal to 0 means open circuit. Okay, that means current equal to 0 means open circuit. Or next one. Okay, resistances or resistors are connected in series. Resistors are connected in series. If the number of resistors are connected in series, for example, if three resistors are connected in series, that is R1, R2, R3, the total resistance RT, the total resistance RT equal to R1 plus R2 plus R3. If number of resistors are connected in series, that is Rn, the total resistance equal to RT equal to R1 plus R2 plus R3 plus and so on plus Rn. When these resistors are connected in series, the total resistance is RT equal to R1 plus R2 plus R3 plus and so on Rn, means the total resistance is increases. The total resistance is increases, and the current through all these resistors is same in case of series. In case of series, the current through all these resistors is same. All these resistors is same. For example, here one circuit is there. Here three resistors are connected in series, R1, R2, R3. Here voltage is given. Then R total equal to, they are connected in series. Connected in series means R total equal to R1 plus R2 plus R3. That is 2 plus 3 plus 5. That equal 10 ohms. The current I equal to V by R. So that is 5 by 10. That is 0.5 amps. Okay. Next one. Resistors are connected in parallel. In case of resistors are connected in parallel, if they are connected in parallel, the total resistance 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on 1 by Rn. 1 by Rn. Here the voltage across all the resistors is same. In case of resistors connected in series, current through all the resistors is equal to same. But in case of parallel connection, the voltage across all the resistors is same. Okay, the voltage across all the resistors is same. Here for calculation, 1 by RT equal to total resistance, 1 by RT equal to 1 by R1, 1 by R2, 1 by R3, that equal to 11 by 6. That means RT equal to 6 by 11 ohms. 6 by 11 ohms. Next passive element is nothing but inductor or inductors. Inductor which opposes the change of current. Which opposes the change of current. Opposes the change of current. In case of resistor, which opposes the flow of current. In case of inductor, which opposes the change of current. In mathematical form, v equal to L di by dt, and here I equal to 1 by L integral v dt. Units of inductance is henries. This is the schematic symbol of inductor. Okay, coming to the analysis, when uh, the inductor have number of turns and the flux linkage is pi, then the inductance, it is a property of inductance L equal to flux linkages by current. Flux linkages, total flux linkages for n turns, n into pi, n pi by current I, that is nothing but mu n square a by L Henry. So that means the inductor is depends on or proportional to number of turns square and proportional to area and inversely proportional to length of the wire, it is very very important formula. The inductance is proportional to number of turns square and also proportional to area of cross section and inversely proportional to length of wire. Next, the energy. The inductor, it stores the energy in the form of magnetic field. In case of capacitor, a capacitor stores the energy in the form of electric field. In case of inductor, it is in the form of magnetic field. The energy stored in inductor equal to half Li square. Next, the inductors connected in series, like series, the total inductance LT, that means L total equal to L1 plus L2 plus and so on Ln. Case of parallel, same as resistance, 1 by LT equal to 1 by L1, 1 by L2, 1 by plus and so on 1 by Ln. Next, DC analysis. As I said earlier, the inductor which opposes the flow, which opposes the change of current. For in case of DC, the change of current is zero. That means if di equal to 0, v equal to 0. V equal to 0 means, already I said earlier, voltage equal to 0 means it is short circuit. So for DC, the inductor act as short circuit. It is very very important bit. Inductor act as short circuit in case of DC. Next passive elements is capacitor, which opposes the change in voltage. In case of inductor, which opposes the change in current, but in case of capacitor, which opposes the change in voltage. This is the schematic symbol of capacitor. Okay, capacitor. Here the formula for current flowing through the capacitor, I equal to C dV by dt. Here V equal to 1 by C integral I dt. And the charge on capacitor, Q equal to CV. This is the formula, charge on capacitor, Q equal to CV. C equal to Q by V. The units of this capacitor is nothing but coulombs. Okay. Coming to the analysis of this capacitor, the capacitor C equal to epsilon A by D. That means the capacitance of capacitor depends on nature of the material. That means E, nature of the material, and plates separation D, and plate area A. So it depends upon area and plate separation and nature of dielectric. But it does not depend upon thickness of the plates. It does not depends upon the thickness of plates. Okay, does not depend upon thickness of plates. It is one of the previous TTA bit, nothing but JE bit. Okay, DC analysis. As said earlier, the capacitor does not allows the change in voltage. Means in case of DC, the change in voltage is 0 because the constant voltage. So for dv equal to 0, then current also 0. I said earlier, if current equal to 0, then circuit act as open circuit. Then circuit is called as open circuit. So the capacitor for DC act as open circuit for DC. So it is very important bit. And the next one, the energy stored in capacitor E equal to half CV square. As I said earlier, the capacitor stores the energy in the form of electric field, but in case of inductor it stores the energy in the form of magnetic field. Next one, the capacitors are connected in series. If the capacitors are connected in series, 1 by C total equal to 1 by C1 plus 1 by C2 plus and so on 1 by Cn. It is reverse of resistance and inductance. Reverse of resistance and inductance. If they are connected in parallel, then C total equal to C1 plus C2 plus and so on Cn. But in case of resistors and inductors, see, if we connected series, they are added, here reverse. Okay, all the best friends, thank you.